Chapter 8. We are going to discuss the confidence interval. We are going to discuss the confidence interval. I will explain to you. For whom? For one population mean gain. Chapter 7, we discussed distribution. Sampling distribution of sample mean. Chapter 8 is mean gain. But we are going to discuss confidence interval. It's good, right? Let me ask you. How do you think? What is my height? How tall am I?
5'1".
5, only 1. How do you think?
I say like 5'2".
5'2"? Oh, you're better.
5'3".
5'3", or getting higher.
I don't think it's tall.
He said 5, 1, 2, 3, and you're next.
5'4".
5'4"?
I don't think you're tall.
No, be honest. Yeah.
I would say 5'3". Probably.
5'3"?
Yeah.
5, 2.5.
5 or 2.5?
5'4".
5'4"?
I'm 5'1", so.
Okay.
This is gonna go 5'5".
5'5".
I don't think I'm correct. I'm gonna.
Why 5'5"? Just guess.
Yeah.
On my driver license, it said 5'3". How do you think? Am I 5'3"? Let me ask you. It said 5'3". Am I exactly 5'3"? No. I made my driver license, they do not measure. It's just guess, right? And just copy the previous one, and even though I renew my driver license, but just copy from the previous one, I made my driver license 20 years ago, right? My height might be 20 years ago, 5 and 3, but now, getting older, then it's a little bit shorter and older, Yeah. I'm not exactly 5'3", but it's about, yeah. But how about this way? My height is 5 feet and 6 feet. Between 5 feet and 6 feet. Okay, let me give you the wider. 4 feet and 6 feet. Is it true? Is my height between 4 feet and 6 feet? Most of people, it's not all of them, but most of people is between 4 feet and 5 feet. 4 feet and 6 feet, right? So that is not a good one, right? But for me, when I say my height is 5'1", yeah, you said it's 5'1" and 5'4". That is more reasonable, right? As probably my height is between 5'1", 5'4", or 5'1", 5'5". Do you agree? Yeah, between 5'1", 5'5", right? So when I comparing 5'1" and 5'5", and 4 feet, 6 feet, both one is true. My height, there, both of them, but we need the more reasonable things, right? That is the confidence interval. In statistics, when we estimate something, we have 2 ways. One is the point estimate. At the beginning, when I asked you what is my height, then all of you said one value, one height, 5'1", 5'2", 5'3", 5'5". That is the point estimate, one value. But what I said is between 5'1" and 5'5", it is the interval estimation. So in chapter 8, we are going to discuss the interval estimation. It's between here and there. That is another way to estimate. For whom? Population mean. You know, one day, I need a space, yeah, here. One day, I gave you big two circles. Here's a population, and here's a sample. We took the sample from the population, right? The mu, sigma, who are they? Population mean and population standard deviation. In the population, one day I said, we don't know anything in the population. That means we don't know how much is the population mean and how much is the population standard deviation. But just before, in chapter 7, we use the population mean and we use the population standard deviation. They were given in chapter 7. What happened? Now, I said we don't know them, but we use them in chapter 7. What's wrong? You know, actually in chapter 7, we assumed we knew them. It's actually we don't know. Actually, we don't know how much is the population mean, population standard deviation. That was the reason why we took the sample and take the sample mean and sample standard deviation to estimate them. So please remember and understand, we assumed we knew them in chapter 7. So any problem from chapter 7, they suggest us what is the population mean and what is the population standard deviation. But actually we don't know them. It's good? So let me go back to the title. Let me go back to the title of the chapter 8. In chapter 8, we are going to discuss confidence interval for population mean. As I told you, confidence interval is an interval estimation. We are going to estimate who? Population mean. Why? Because we don't know. But we want to know what is a population mean. So it suggests, there is a definition of the point estimate. And here is the confidence intervals. So we are going to discuss what is the confidence level and confidence interval estimation. So can you understand what we are going to do? So it's actually we are going to discuss interval estimation. Here it is. So here's the interval. This one from here to here. What's the difference? It looks similar. What is the difference between the first one and the second one? Confidence interval for unknown mu. You know, the mu was the symbol for the population mean. From the first one to the second one. What's the difference? Here's a minus sign. Here's a plus sign. Can you see that? So let me rewrite the formula. In the middle, we take x bar. And then plus and minus z times sigma over square root of n. Who is this? It will be the confidence interval for, I want to say, unknown population mean. Who was the X bar? Can you remember who was the X bar? Sample mean. Absolutely, the sample mean was in the sample. Sample mean, it is the point estimate for unknown population mean. It is the point. I told you the point estimate was just one value, the one estimation. Unknown population mean. So we just put the sample mean, the point estimate for the population mean in the middle, and then plus and minus, because we have to make the interval. The minus one will be the smaller one. The addition one will be the bigger one from here to here. Have you ever seen the Z notation, the symbol Z before? What does that mean, Z before? We took a Z-score. We took a Z-score from a Z-table. Do you remember that? We took not only probability, but also reverse way, we took the Z-score. Yeah, it is a Z-score from the Z-table. So we are going to take the Z-score from the Z-table. It's a Z-score. From the standard normal distribution. And now the last one. Have you ever seen sigma over square root of n? Where? Just before chapter 7. Who was this? It was the standard deviation of whom? Sample mean. Okay? So we are going to make the interval 1 from minus sign, subtraction, take the smaller one, and plus 1, take the bigger one. So from smaller one to the bigger one, but in the middle, we plug the point estimate, sample mean. And we plug at the end, it is the standard deviation of the sample mean. And we are going to take the Z-score. We are going to take a constant from the Z-table. So it is the form for confidence interval for unknown population mean. It's good? Okay, here's an example. In this example, it has the 36 sample. We are going to make confidence interval estimation for unknown population mean. So we took a sample, 36. Then here is the point estimate, X bar. Who was the X bar? Sample mean. I gave you the sum here and divide by 36. The sum is, let me bigger, 2278 divided by 36. The summation, the sum of 36 prices for mobile homes. The summation was 2278, I think in thousand maybe, yeah, and divide by 36. Can you give me the sample mean X bar from the sample 36? 63.28.
Yes.
Thank you. But now, even we assume we knew the sigma. I told you we don't know anything in the population. Do you remember that? So now, we don't know what is the mu. We don't know what is the population mean. So we want to estimate. We want to make the interval estimation for unknown population mean. But still, we assumed we don't know the population standard deviation. Later, we are going to say we don't know the sigma. Okay? The sigma as well. But at the beginning, we just break the assumptions one by one. So before, in chapter 7, we made assumptions. We knew the mu, population mean, and we knew the sigma. But now, we don't know what is the mu, population mean, but we knew the sigma. Later, we are going to say we don't know the population mean, we don't know the sigma either, right? But now, because the formula was x bar plus n minus the z time, here was the sigma. So we need the sigma. Later, we are not going to use the sigma. It's a little bit different way. Okay, who was the x bar? See, we need the x bar here. Sample mean, the point estimate of the price, mobile home was 63.28 plus and minus. Let me take the z-score later from the z-table. Okay, I just plug into what were given. We are going to take the z is later, is here. Sigma was given, assumed we knew the sigma 7.2. Square root of how many sample? 36. It is the same thing. Sample mean will be given. Sigma will be assumed to know. Sample size will be given. Everything will be given. So at least you have to remember what is the formula and just plug into one by one. It's good, right? Okay, so now the problem is how can we take the z-score? For the z-score, before we needed the probability, right? So now we need the probability. For example, we need, it's not just confidence interval, but specifically, we can say we need the 95% confidence interval. So let me try to take 95% confidence interval. Let me write here, it's 95% confidence interval for unknown population mean again. So always, it's not only the sample mean, sigma, or sample size, but also always we are going to have that kind of the percentages. It has the name confidence level. Confidence level. It might be 99%, 90%, any kind of percentages. So as we did from a given probability, we can take the z-score. Do you remember how did you get the z-score from a given probability? You know, sometimes the probability was given at the left end. Sometimes it was given on the right end. And sometimes it was in the middle. Do you remember that? Confidence level, 95%. It is always in the middle. So please look at this picture. Let me make this one bigger. The very first one. Just a second. In this picture, on this picture, it's not just 95%, but exactly 0.9544 is given in the middle. Can you try 1 minus 0.9544? 1 minus 0.9544? How much will be? 0.04, 5, and 6. Where is the probability? 0.04, 5, and 6. Can you remember what I did? 1 minus in the middle? You know, 1 minus in the middle means left end, right end together. Can you do divide by 2? We took 1 minus the middle probability. 1 minus 0.9544. We took 0.0456. And please do divide by 2. What do you get?
0.0228.
Did you get 0.0228 and 0.0228? Can you understand what I'm saying? In the middle, there is a probability 0.9544. Then the left end, there is a probability 0.0228. Left, right. Sorry, the right end, there is the same probability 0.0228 because the normal distribution is symmetrical. And add them up, it will be 100%. It sounds good, right? So now, if I need the z-score here, then I have to look for the probability from the z-table. Please look for the probability 0.0228 on the page with the negative z-scores. What is the z-score? Exactly -2. Then simply we can expect the right one, it will be +2. Why not? It's good, right? So now 0.9544 is not exactly 0.95, but it is the confidence level. What did I say? Always the confidence level in the middle. Let me try one more example. It is a general one. Okay, then now let me try 95%. We are going to take the z-score. So let me make the standard normal distribution. The z. We tried to make the 95% confidence interval, right? So now I have to plug 95% in the middle. please try 1 minus 0.95. 1 minus 0.95. How much? 0.05. You know, actually the 5% is the left end and right end together, right? So we have to do one more step, divide by 2. How much will be? 0.025. Then now, where is the probability 0.025? On the left and on the right, the same probability. So I need the negative z-score here. So now I have to look for the probability 0.025 to the left to get the z-score. Try. How much would be? Probably you can see exact probability 0.0250 at a z-score negative 1.96. Please go to the z-score negative 1.9 and 6. Exactly, you can see the probability 0.0250. Then how do you think? What will be the other one? Positive 1.96. But let me try. Look for how much here? You know, here, only this one. That is the 0.025. In the middle, how much was it in the middle? You know, the confidence level. The confidence level was 0.95. So can you add 0.025 plus 0.95? To the left, the whole probability will be 0.975. Does it make sense? So on the other page, please look for the probability 0.975, please. Probably you can see exact probability 0.9750 at a z-score positive 1.96. Can you see the z-score positive 1.96 with the probability 0.975? Yeah? So the z-score for the 95% confidence level, 95% confidence interval, it will be plus and minus 1.96. So let me go back to the example. Yes, here, this one. We plugged the others except the z-score. But we found the z-score from the z-table, from the confidence level, 95% in the middle. They were plus and minus 1.96. Can you take the second part, please? 1.96 times 7.2 over square root of 36, please. The second part. How much?
23.52.
Say again?
23.52.
23.52. But the beginning, there was the point estimate, sample mean.
I got 2.352.
just a second. $2.3?
Mm-hmm.
Anybody? You got 2.3?
Yeah, that's right.
Yeah. Probably you plug the wrong decimal place somewhere. Okay, it's good. So it is the 95% confidence interval for unknown population mean. If you have enough time, absolutely. Can you take the subtraction, please? 63.28 minus 2.352, please. What? 60.928, comma. How about the addition? Even we can make the interval form from here to here. That is another good answer for 95% confidence interval for unknown population mean. So either way, simply you just the point estimate, sample mean, plus and minus the second part. Yeah, it is a good one. Plus and minus form or interval form, the either one will be fine.